In this video, we're going to talk about dispersion as a descriptive statistic and how we use it to interpret information. So as a general rule, when we're using mean and standard deviation as descriptive statistics, about 68% of the scores will be within one standard deviation above the mean and one standard deviation below the mean. You're going to want to write down this number. We're going to be using this a lot. 68% of the scores are within one standard deviation of the mean, either above or below. And here's another one to write down. About 95% of the scores will be within two standard deviations of the mean. That means two standard deviations above and two standard deviations below. Let's take a look at this graph of the Wechsler Intelligence Scale to get a better sense of how we can use standard deviations and means together. So the mean of the Wechsler Intelligence Test is 100 and the standard deviation is 15. So I can use this information to know about where 68% of the scores are. And I can find the scores at one standard deviation above and one standard deviation below. So how do I do that? Well, I take my mean of 100 and I add 15 points, the standard deviation, to find the score at one standard deviation above. And lo and behold, there it is, 115. I do the reverse to find one standard deviation below. I take the mean of 100 and I subtract one standard deviation of 15 and I get a score of 85. From what I know about standard deviation is that 68% of the scores are between 85 and 115. So we can also do the same process to find the scores at plus or minus two standard deviations. So we start at the mean of 100, and instead of adding one standard deviation, we just add two. So instead of adding 15, we add 30, and we end up with a score of 130 at two standard deviations above the mean. We're going to reverse it to go backwards. So I take the mean of 100 and I subtract 15 twice to get to a score of 70. Now at plus or minus two standard deviations, I know that 95% of the scores are there. So 95% of the scores are between an IQ score of 70 and 130. Wow, okay. So anything beyond this two standard deviations, I'm going to consider those extreme scores, right? Okay, so in sum, you're going to want to remember that 68% is plus or minus one standard deviation, and 95% means plus or minus two standard deviations from the mean. All right, let's practice with this. Here's a learning check. A distribution has a mean of 20 with a standard deviation of 8. What scores are represented at plus or minus one standard deviation? So think about that. We know we can start with the mean of 8. What's one above? What's one standard deviation below? Well, here it is. We had a standard deviation of 8 and our mean was 20. So we just added 8 to get to 28 and we subtracted 8 to get to 12. This represents 68% of the scores in the distribution at plus or minus one standard deviation. Here's another one. A distribution has a mean of 20 with a standard deviation of 8. What values represent where 95% of the scores will fall? Okay, we just have to remember back. What does 95% mean? So now we have the scores of 4 and 36 that are the boundaries for 95% of the scores. How did we get that? Well, the standard deviation is 8. So if I add one standard deviation to 20, it's 28. If I add two standard deviations, it's 36. And the same, 8 plus 8 is 16. So two standard deviations below 20 is 4. So there you go. 4 and 36 are the scores that encompass 95% of the distribution. A distribution has a mean of 20 with a standard deviation of 8. What scores are represented at plus or minus one standard deviation? Well, we've already done the actual scores, but I want you to think about it this way. It's the same thing as saying 68% of the scores are within plus or minus one standard deviation. I'm repeating myself a lot, but that's on purpose. Okay, a distribution has a mean of 20 with a standard deviation of 8. What values represent where 95% of the scores will fall? It's the same thing as saying plus or minus 2 standard deviations. I only do this to illustrate that you can say it one of two ways. You can say plus or minus 1 standard deviation, or 68% of the scores. Or you can say plus or minus 2 standard deviations means 95% of the scores. All right, this one is tricky, but you can do this. If a population has a mean of 50 and a standard deviation of 10, would a score of 58 be considered an extreme value? And then I want you to think, what if the score were, the standard deviation were 3? It's going to be different. So let's take a look. Think about it first, pause the computer, and then come back and take a look. So what I have here are the two distributions that I just talked about. This one has a mean of 50 and a standard deviation of 10. This one has a mean of 50 with a standard deviation of 3. And I've indicated the standard deviations below. So if I have a standard deviation of 10, one standard deviation here is 60, and the next one is 70. I'm just adding 10 with each standard deviation and subtracting 10 with each standard deviation on the other side. So what I'm going to do is I'm going to indicate where our score is. Our score, as a reminder, was 58. So in this, I'm going to put my score of 58 somewhere between 50 and 60. It's about right here. Okay, so I'm going to put 58 right there. Now let's think about this. How many standard deviations is that? What standard deviation is it close to? It's pretty close to 1 standard deviation right there. All right, so let's take a look at it in this case. We have the same mean, but this time the standard deviation is 3. So I just added 3 for the first standard deviation. I added another 3 for the second standard deviation. I subtracted 3 and another 3 here. So in this case, the score of 58, I have to find a close score, 56. And now I'm going to put 58 right here. 58. Okay. All of a sudden, I see a difference. This score is much further out into the tail, isn't it, than this score right here. Now, if I think about it, what I'm going to consider extreme are going to be anything beyond plus or minus 2 standard deviations. I'm going to call this my extreme area here. All right. Any scores within these extreme areas, I would say, are extreme. So in the first case, when we had a mean of 50 and a standard deviation of 10, our score of 58 is not very extreme. It's not very unusual. It's pretty close to the mean in this case. However, when we look at it this way, our score becomes much more extreme. It is further away owing to this smaller standard deviation. So the scores don't vary as much here. So to have a score way out there at 58, it's very extreme. So in this case, 58 would be an extreme score in this situation, but it wouldn't be an extreme score in this situation. Does that make sense? So in sum, the score of 58 is not considered extreme when the standard deviation is 10 because it's less than 2 standard deviations from the mean. But a score of 58, same score, would be considered an extreme value if the standard deviation were 3 because it would be more than 2 standard deviations above the mean. All right, I'll see you in the next video where we start to talk about samples.